All right, we are going to work on vectors, okay? So what I'm going to show you here is very, very simple. I know people have a problem when it comes to the vectors. Seems like it's difficult, but no, vectors are very, very simple. So now I want to show you something. What is the vector? Okay, the vector, let's say this line. You see, this is a vector, okay? So if I can put it on the Cartesian plane, this x is, this is y, okay, my drawing, okay, let's just say like this, y, x is okay. So if we say this is a vector u, okay, it will be written like this. Now, what represents a vector u? We see the distance from 0 to this point, okay? We call it u1, all right? And then this distance, we call it u2. So this represents our x, this represents our y. So this is the point of our vector. So the vector will be u1 and u2. So this is what represents our vector. Okay. So what we call norm. The norm of a vector, means the distance, okay? The length or the distance of a u. How big is the u? So we're going to do it here. And I will show you how to find the component of a vector. If you have two vectors, to have a component of a vector. So what we can call the component of vectors, for example, I have a vector u, okay, I have a vector v. So the component of a vector will be, you take a parallel here of a vector v. Okay, this is a parallel of v. And this side we have a parallel of u. All right. So, and then we draw the line here. So this is called vector component or component of the vector u and the v. So it will be written like this. All right. Okay. Now let us try to work on it now. Okay. It's very simple. Now we start with vector component. Vector component, or we'll say component of vectors. Component of vectors, okay? Now, what will be the component of a vectors? Very simple. If you have a vector u with a coordinate u1 and a u2, and you have the vector v, where you have a v1 and a v2, what will be the component of a vector will be written like this, u, v, and they have one line, means that will give you one vector. Now what is very simple here, you'll take v1 minus u1 and the v2 minus u2. So this is the component of vectors. For example, you have the coordinates 1 and 2. This is a vector A, and a vector B will be 4, 7. So the vector component, or the component of a vector, will be AB. Alright? So where you'll say 4 minus 1 and a 7 minus 2. So the component of a vector will be vector AB will be 3 and a 5. So this is what we call a component of a vectors. So simple. Now, what is the norm? Let's move to the norm of a vector. Number 2, or before we go to the norm of a vector, yeah, I think we have to move to the norm of a vector. Okay, norm of vectors, of a vector. So what is the norm of a vector? For example, if you have a vector when you have a vector u with the u1, u2, and a vector v with v1, v2. Alright, so the norm of a vector uv will be, first you get the component of vector, which will be this. Alright, and then it will give you the square root. Let me call it u, the vector component here. If you get the vector component, which means will be v1 minus u1 all squared, and we'll have v2 or v1, sorry, minus u1. Let me do this. v1 minus u1 and v2 minus u2 all squared. Okay? Or very simple way to do it, I want to give you an example. If we look at the question that we have, the vector that we have, the component of a vector that we have here. Okay, sorry. I want just to erase this. All right, it's fine now. Okay, now if you have a vector, for example, vector u, we have 2 and you have 1, and a vector v, you have 3 and 4. So what will be the norm of this vector? First of all, you have to find the component of a vector. Okay, the component of a vector vector uv, which will give you 3 minus 1 and a 3 minus 2, sorry, and a 4 minus 1. So we found that the vector component, or the component of a vector, will give us 1 and a 3. So what will be the norm? The norm of this vector will be uv square root equal to the square root of 1 squared plus 3 squared. So this will give you square root of 10. So this is basically how you calculate the norm. Very simple. You can take another example of the two vectors. You do the same thing. I want to give you another example quickly before we go to addition of the vectors. All right. Now, example number 2. You have a 1 to 2. This is the first vector, and a vector b is 4, 7. This is vector b. So what will be the norm of this vector? First thing, find the components of these two vectors. Will be AB, all right, where we have a 4 minus 1 and a 7 minus 2. So the component of this vector will give you 3 and a 5. All right. So now, what will be the norm? The norm of this vector will be square root of 3 squared plus 5 squared. So this will give us 9 plus 25. So this will give you square root of 34. So this is how basically you calculate the norm. Next one, we look at what we call the addition of vectors. The addition of vectors. Okay. Addition of vectors. That sounds like H. Looks like H. Okay, the addition of vectors. For example, you have a vector u, u1, u2, vector v, v1, v2. What is the addition of these two vectors? You just say u1 plus v1 and the component u2 plus v2. Very simple. Example, you have vector u1 minus 2 and the vector v, which have 3 All right. So what will be the addition of these vectors? vector u plus vector v will be 1 plus 3 and minus 2 plus 3. So this vector, the addition of these two vectors will give us 4 and a 1. Thank you. This is basically what we can do. If you have a question, you can ask. If you have a suggestion, you can do it. If you have a donation, as I always say, this is the tuition of a refugee man who's trying to help people. Thank you so much. Next video, we are going to do the opposite of the vectors, and we are going to do the determinants, and we are going to do the matrix, and we are going also to do the inverse of a matrix. Thank you.